So today's lesson is about when a quadratic function is written in vertex form. And before I really go into this, I wanted to reflect back onto what the parent function looks like, because we're going to keep referring back to it, so we really need to have a good understanding of this. Okay, so the parent quadratic function is, if I were to plug these in, and the reason why I want to go through this with you is in case you forget. All right, you can always recreate the parent function. Okay, I'm going to plug in -2. -2 squared is 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. Okay, when I graph this, -2, 2, 3, 4. Okay, so now I want to take a look, and we know that this goes on forever, right? Like this goes up and up. So when we look here, the vertex is at the origin. The vertex is 0, 0. Now, there's something I'm going to talk to you about in a minute, but if we notice here, the parent function, right, to get from this to the next point, I go up 1 and over 1, and then to get to this point from the vertex, I go up 4 over 2. Okay, so, and it opens upward. These are just some things that I'm noticing. Every single quadratic function is going to be symmetrical. The vertex isn't always going to be here, and it's, sometimes going to get skinnier or wider or shift left, shift right, reflect, all of those things. But the basic parent function, it opens upwards. The ratio here is like 1, to get to that one, it's 1 up, 1 over, and then 4 up, 2 over, okay? So now, it's important to know what the parent function looks like, because we can graph a quadratic function that is in vertex form very easily if we are comfortable with a parent function, okay? And there's some key things that we're going to talk about that I'm going to show you. If you look up here, this is the quadratic parent, this is the vertex form of a quadratic function. Okay, and I know it seems a little bit like, oh, I got to remember another equation, but sometimes, you don't really need to know that that's A, that's H, and that's K, although it, it will help you figure all this other stuff out about how to graph it. All right, so if we have an equation in vertex form, then the vertex is just HK. So the vertex, if this, let's say this was a 3 right here, now because there's a -3 and this is the opposite, this would just be a 3, and then K is right there. So I don't have to do any calculations. I can just say HK, that is the vertex, all right? Now, this A out here tells me if it's going to be a stretch. Remember, stretch is when it's getting skinnier, the parabola, or a compression when it's getting wider. It's going to tell me if it's opening upward or downward, if it's going to reflect. It's telling me, is it going to shift left or right? And then the K means, is it going to be shifted up or shifted down? Okay, the axis of symmetry is right here, is whatever H is, and I usually like to look at it right here. Okay, so there's some key elements that we can figure out once it's in vertex form. It's a little bit harder to do all that when it's in standard form. Okay, so we're going to practice graphing, and I wrote a few steps down here, and then I started to graph it, and I was like, wait a second, I should, put this whole thing on the video so you can see. All right, so here's the function. Graph f of x equals -2, x plus 1 squared plus 5. So the first thing I'm going to do is find the vertex, all right? And I know the vertex is just here. It's the opposite of this, -1 and 5. All right, so now I can plot the vertex, -1, 5, and I already did that. Okay, to get to my next point, now if I reflect back to what the parent function was, right? The parent function, basically to go from the first point to the second point, I went up 1 over 1. All right, we know that this function right here is going to reflect, so it's going to end up looking this way. And we know it's going to be skinnier than the parent function, all right? Well, it's going to be twice as skinny. So instead of going up 1 over 1, it's almost like I'm going up 2 over 1. I'm going to multiply that by 2, and instead of going up, I'm going down because that's a negative. So I'm going to go down 2 over 1. All right, and then I'm going to reflect that on the other side. all right? Now I also know when I go back, so let me put these coordinates here, okay? So it's almost like I went down 2 over 1. So my coordinate was 0, 3, and then I had -2, 3. Okay, now step 3 just says you use the line of symmetry to plot the other point. So what that's saying is these are always going to be symmetrical. So I plotted this point, and then I'm going to use the other line of symmetry, and it should look not so much like a V. It's kind of like a V. It should look more like a U. Okay, so now to find my next point, if I go back to the parent function, right, I had a ratio here. I went up 1 over 1. Now I went up 4 over 2. So it's going to get skinnier. Instead of going up 4 from the vertex, I'm going to go do 8, okay, because I'm doubling it. 1, 2, 3, 4, 5, 6, 7, 8 over 2. All right, and then I'm going to reflect it on the other side right here. Okay, so that coordinate was 1, 3, and this was 1, 2, -3. Okay, so on this particular one, what did we do? I used the vertex. I found the vertex first and plotted that, and then I thought back to the parent function and the ratio here and said, okay, instead of going up 1, now I'm going to double it and go 2, but I have to go down since that's a negative, and then the difference over here was 4, and so now it's going to be 8. Okay, that's kind of how I worked it out. Now, I do have to remind you that if you want, you can always, if you're going, oh my gosh, Miss Knight, I'm going to get confused a little bit on this, you know, on this remembering the ratio and parent function. It seems like I think I might forget that. You can always make an XY table. And once you have the vertex, see how the vertex is -1, 5? Well, then just pick 2 points on one side of it. So that's 0, 1, 2 points on the other side of it. And you can always fill those into the equation. All right, if I fill in 0 into here, that's the x value. 0 plus 1 is 1. 1 squared is 1. 1 times -2 is -2. -2 plus 5 is 3. And look, that's what we got. All right, and then same thing. You can plug in 1. 1 plus 1 is 2, 2 squared is 4, 4 times -2 is -8, -8 plus 3 is -3. Oh my goodness, I'm now realizing I didn't put my negatives. Here, 0, 0, 3. This should have been 1, -3. Sorry about that, 1, -3. Yep. Okay, plug in -2. And we know that this should be a total reflection. So here, when I plug this in, I should get 3. -2 plus 1 is -1. -1 squared is 1. 1 times -2 is -2. -2 plus 5 is 3. And you would do the same here. Okay? All right. So let's practice. Okay, the first thing, so we have this graph. I'm trying to zoom in a little bit. The first thing that we're going to do is find the vertex. All right, well, the vertex, I do the opposite of this. So the vertex is 2, -1. Oh, sorry. Goodness gracious. Opposite of this one, the same as that one, 2, 1, 2, 1. So I'm going to plot the vertex. I know that this is going to be going down, so I should have like a sad face. I know it's going to be getting skinnier than a normal parent function by 3 times. Okay, it's going to be, and I've kind of already shifted my vertex, right? It's gone right 2, up 1. Okay, the axis of symmetry is where I, where it can reflect over, and it's always going to be the x value of the vertex, so x equals 2. All right, that kind of gives me a few things. So when I start graphing this, I have a little picture in my head so that if it goes wrong, I'm going, wait a second, I made a mistake somewhere. Okay. So now what I'm going to do is I'm saying, well, to get to the next point, usually the parent function, now I know I'm going down, usually the parent function is 1 over, and 1 down, 1 over, but this is getting skinnier. So this is going to be 3, 1. And I can reflect it over here. All right. Well, I remember that ratio is 1 and then 4. So now I have to do 4 times 3 is 12. So now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm kind of running into this, so I'm just going to make it look like that, pretty steep. Okay. Let's go down to this one, vertex. And then you'll start getting quicker and quicker as you're doing this. The opposite of 1, the same, the axis of symmetry is x equals -1. Remember, it's always that x value. Okay, I'm going to plot this, -1, -4. Now, I don't see an A here. So if I don't see an A, it's 1, which means it's positive, which means it's going to go open. It's going to be like a smiley face. And I know that I shifted it left 1, down 4, so that looks right. It's going to be the same ratio as a parent function, so it's going to be up 1 over 1, and I can always double check it. Remember, if you don't feel good about that, you can always plug in here, x is 0, 0 plus 1 is 1, 1 squared is 1, 1 minus 4 is -3, so it looks like we're right. And then we have, the next one is 4, 1, 2, 3, 4 over 2. Okay, for this part, forgot to write those in again. Okay, so now what I want you to do over here is you come up with the equation. Well, when I think about this used to stress me out until I learned about vertex form. So f of x equals ax minus h squared plus k. All right, so the first thing I'm going to talk about is the vertex. Well, what is the coordinates for this vertex? 1, 2, 3, -3, -1. So I know right now that if I plug in a -3 here, this is going to be -3. So I'm going to have x plus 3, and I remember that it's the opposite once I go there, and this stays the same. Okay, let me look at this. See how this is going up 1 over 1? So this is the same thing as a parent function. So I don't have to worry about putting anything there. And it's a smiley face, so it's positive. All right. So down here, I was supposed to add a few things. So let me just, add this really quickly. Okay, so we are going to just identify the vertex and axis of symmetry for these functions. And at first when I looked at it, I was like, oh my gosh, vertex form usually has parentheses, a whole lot going on here usually. Why is this one, doesn't look like these? These are much more detail to them. Well, so what is it missing, or what does it have? It looks like it doesn't have an A. It doesn't have the H, right? Because nothing's in parentheses, but it does have the K. So if I were to find the vertex, right, if it doesn't have the H, that means it's a 0, and that's -1. That's my K. So the vertex is 0, -1. Now, when I go back, I also say, wait a second, okay, this is the parent function, and it shifted down 1. So if I think of my parent function, right, it shifted down 1, the vertex would be 0, -1. So we're in the right place. Okay, the axis of symmetry is x equals 0. All right, let's look at this one. So this one, what's happening here? Once again, not a whole lot going on, but it looks like it's being shifted right 3. Okay, so my vertex, this time I'm going right or left, and I don't have anything on the end. Okay, so my axis of symmetry is 3. All right, on this next section, I wanted to compare, and I made up 2 equations. So let's compare these. I forgot to write them in. Let's try f of x equals 2x plus 1 squared plus 4. So what does this tell us? Let's see, what is the vertex? Let's start off with that. Okay, the vertex is the opposite of this, -1, 4. The axis of symmetry, sometimes people will say AOS, axis of symmetry is x equals -1. Direction of the graph, well, that's what we're looking here. It is going to be opening up. It's positive, it's like a smiley face. It's going to be opening that way. And then let's compare it to the parent function, is it going to be wider or is it going to be narrower? Well, it's a positive number. It's going to be a stretch, which means it's going to be narrower than the parent function. All right, so that's just something that you can use to compare. You know, the vertex form really does a good job of making it easy to compare it to a parent function. All right, and then you can graph it with everything you know. All right, have a good day.